relationship between absolute value and ordering numbers. So in the opening exercise, we're asked to record the integer values that were given in class in order from least to greatest. So I will suggest the numbers -12, -9, -5, -2, -1, 0, 2, 5, 7, and 8, and those are in order from least to greatest. Then we're asked to write an inequality statement relating the ordered integers from the opening exercise. And as you can see, from least to greatest, we would be using a less than sign in between each pair of numbers. And I also showed it a second way by ordering them from greatest to least, and when you order them greatest to least, you put a greater than sign in between them. It makes lots of sense if you go ahead and read it. -12 is less than -9, which is less than -5, which is less than -2, which is less than -1, which is less than 0, which is less than 2, which is less than 5, which is less than 7, which is less than 8. And then underneath, the inequality statement, we were asked to write the integer, to write its absolute value. Now, in the second question, there's a follow-up question in between there. The follow-up question is, are the numbers the absolute values in order from least to greatest? And when you look at them, you can see that they are not, because the absolute value of -12, which is 12, is listed as the smallest number on the list, when in reality it is actually the largest number. So the next step is to circle the absolute values that are in increasing numerical order. As well as their matching integers. So I've circled 0, 2, 5, 7, and 8 because both the original integers and the absolute values are in order from least to greatest. The other numbers, you'll notice that 1, the absolute value of -1, is written to the left of 0, and 1 is definitely not less than 0. Now, in the second step, we're going to rewrite the integers that are not circled in this space, the integer part, not the absolute values, and then say how they are different from the ones circled. -12, -9, -5, -2, and -1. And they are different from the ones that are circled in the fact that they have negative signs in front of them. They are negative. Then they ask us to rewrite the negative integers in ascending order and their absolute values in ascending order below them. So in ascending order, from least to greatest, we have -12, -9, -5, -2, and -1. But the absolute values, if we write them in ascending order, remember these are the absolute values. The absolute values would be 1, 2, 5, 9, and 12. So if we're going to describe how the order of the absolute values compares to the order of the negative integers, we could say that the order of their absolute values is opposite. Next, we'll take on the number line and show some patterns. So if we draw arrows starting at the dashed line, which is our 0, and represent each of the integers, then, for example, if we were going to represent if we were going to represent 3, we would start at 0. And go to 3. And if we wanted to represent 4, we would start at 0 and go to 4, and representing 5 would start at 0 and go to 5. The same thing is true for our negative integers. For -1, we would start at 0 and go to -1. For -2, we would start at 0 and go to -2. Likewise for -3, -4, and -5. So as we approach 0 from the left on the number line, the integers increase. In other words, the value of the integers increase, but the absolute values of those integers decrease. And this means that the order of negative integers is opposite the order of their absolute values. Continuing on, in exercise 1, we have a set of rational numbers, a whole variety of types of numbers, and they're asking us to separate the set of numbers into positive and negative values and 0, and then we'll continue on after that in putting their absolute values into the cells underneath them. So the negative rational numbers that we have are -4 1/2. So we can see the negative rational numbers are -4 1/2, -6 25 thousandths, -1 5 tenths, -3 or 6 3 tenths, -4, and -9 1/4. There is a 0 in the list. It goes in the middle. And the positive rational numbers were 2 1/10, 25 hundredths, 3 9 tenths, 2 3/4, and 3 99 100ths. Next, we're going to write the absolute values of those rational numbers in no particular order in the cells right below our original cells. And so we have their absolute values in the cells below. And once we've put each of those sets in order, we can first of all see very clearly that for the negative rational numbers, the order of their absolute values and the order of their actual values are opposite. But for the positive rational numbers, the orders of their absolute values and their regular order are exactly the same. And then to order the entire given set of rational numbers, we would take the rational number and the sign that goes with it and compare them and put them in order like so. Now in exercise 2, our final exercise, we're going to just practice finding numbers that fit some criteria. 2a asks us to find a set of 4 integers such that their order and that of the order of their absolute values is the same. And so your answers may vary, but in order for the order of the integers and the order of their absolute values to be the same, they must be positive numbers and or 0 included in the set, but they cannot be negative. So for example, I could say 2, 4, 6, and 8, and their absolute values would have the same order as well. 2b asks us to find a set of 4 integers such that their order and the order of their absolute values are opposite. And in this case, in order for their normal order and their absolute value orders to be opposite, they have to be negative integers. So I could, for example, say -8, -6, -4, -2. 2c asks us, find a set of 4 non-integer rational numbers such that their order and the order of their absolute values is the same. And so in the same way, you could have an infinite number of combinations, but all of your numbers must be 0 or positive in order for the order of their absolute values to be the same. So perhaps I have 0, 1 and 5/10, 3 and 1/4, and 6 and 3/10. I guess our 0 doesn't meet that criteria. We'll call it 0 and 1/10. And then in 2d, they ask us to find a set of 4 non-integer rational numbers such that their order and the order of their absolute values are opposite. And so in this case, they must all be negative. And we could say -10 and 1/7, -8 and 33/100, -5 and 1/4, and -3 and 6/10. Again, yours may differ, but they must all be negative. Then it asks us to order all of our numbers from A through D, and there'll be 16 of those numbers from least to greatest. So the lowest, the least value, would be -10 and 1/7. Then we would have -8 and 33/100. Then we would have -8 up here. Then -6, -5 and 1/4, -4, -3 and 6/10, and -2. Then looking at our positive numbers, we have 0 and 1/10, 1 and 5/10. Up above, we have 2, and then 3 and 1/4. There was a 4 up above, a 6 up above, and 6 and 3/10, and finally 8 was the largest number on our list. Remember, the absolute values of positive numbers will always have the same order as the positive numbers themselves. Negative numbers, however, have exactly the same order, have exactly the opposite order as their absolute values. The absolute values of numbers on the number line increase as you move away from 0 in either direction.